Hello guys, and welcome back to this video. In this video I'm going to show you how to get the inverse of a 2 by 2 matrix, the quickest way to do it, the easiest method. So to get the inverse of a 2 by 2 matrix, normally we'd use this formula over here, which is for matrix A. To get the inverse of the matrix, we just have to multiply the adjunct of that matrix, or rather you can just divide the adjunct of that matrix by the determinant. So basically we multiply 1 over the determinant of the matrix A times the adjunct of matrix A. We know already the method for finding the adjunct of a matrix and determinant of a matrix, so we'll just do that, and we can use that video which is in the description below to know how to do your scalar multiplication of matrices, because this is basically a scalar multiplication. So we could either use this method or we could use our calculator. The video for how to use your calculator to get the inverse of a matrix is in the description box below, so you can go watch that video. It's going to be useful for getting the inverse of different kind of matrices 3 by 3, and the rest is going to save you a lot of time during tests and exams, or whatever you want to use it for. So besides that, there's a method that's actually quicker than using a calculator, and this is the quickest method for finding the inverse of a 2 by 2 matrix. You should note that this only works for a 2 by 2 matrix. So basically, if you have a matrix, like this, let's say P, Q, R, and S, the inverse of the matrix can be gotten basically by interchanging the positions of the elements P and S. So the diagonals here would just be interchanged such that P would come to the position of S and S would come to the position of P. Then changing the signs of Q and R. So the other diagonal on this other side, we're going to have Q, since here this is positive Q, Q would become negative Q, and over here this is positive R, so positive R would become negative R, and that's basically it. Then after that we just have to multiply the new matrix we have by the reciprocal of the determinant of the whole matrix P, Q, R, and S. So basically following that method, and we can always confirm our answers for the determinants of a matrix, for the inverse of a matrix, to see if what we did was actually correct by using this, because it's one of the properties of a matrix, such that if you multiply the matrix A by the inverse, we are supposed to get an identity matrix such that we have 1 1 and zeros. So you can always use this to confirm your answers. So let's try that with an example. Let's say we have a matrix A, which is equal to 1, 2, 3, and 4. So remember, the first step for getting the inverse of a 2 by 2 matrix is basically by interchanging this and this. So we're going to have 4, 1, and then do 3. So this and this have been interchanged. Notice that. So the next step is to interchange the signs. So you can see that 3 and 2, the signs of 3 and 2 should just be interchanged. So this and this is already done. So write that back. So -2 and -3. We've interchanged the sign. The next step is to basically multiply this new matrix that we have, which is 4, -2, -3, and 1, by the reciprocal of the determinant of the matrix A. We can use our calculator to get the determinant of the matrix A. You can watch the video for how to use your calculator to get the determinant of the matrix A. The video is down in the description below. So now, once you've gotten the determinants, we can just use it the old-fashioned way. To get the determinant of a matrix is just basically to use the cofactor of that matrix. So basically just multiply this by this, minus this times this. So we have 4 times 1 minus negative 2 times negative 3. So 4 times 1 is 4 minus negative 2 times negative 3. This will cancel this, leaving us with 6. We have the determinant of this matrix A as negative 2. Now all we have to do is multiply the reciprocal of this new number over here, which is the determinant of A, by this new matrix using scalar multiplication. Now you can use your calculator to do this, but it is basically easier to just do this using your hand. So we have 1 over negative 2 divided by 4 minus 2 minus 3 and then 1. So if you multiply this by, if you do for scalar multiplication, it's just basically multiplying every single element in that matrix by what we have here, by the scalar over here. So this is equivalent to this times this is negative 2, this times this is 1, this times this is 3 over 2, then this times this is negative because we have this plus and this negative. Yeah, so it matches the answer we have here. And to confirm, we can use this to confirm our answer to see if our answer is right. So when we multiply this original matrix A by the new inverse gotten over here, we should get an identity matrix. So let's try that out. You can use your calculator to do this matrix multiplication, and the video for that is right in the description box below. So basically the method for multiplying two matrices is by multiplying the sum of the rows by the sum of the columns. So we're going to have something like this. So now 1 times negative 2 is negative 2, and then we add plus 2 times 3 over 2, that's 6 over 2, which is basically equals to 3. I'm gonna have 3 here. So now for the second column of the first row, we do that now using the second column of this first row. So now 1 times 1, that's 1, plus 2 times minus 1 over 2, and that's simply basically negative 1. So next, to get the second row of the first column, we multiply the second row of this by the first column over here. So we have 3 times minus 2, that's minus 6, plus 4 times 3 divided by 2, that's 12 divided by 2, and that's 6. So now to get the second row of the second column, we multiply the second row here by the second column over here. So 3 times 1, that's 3, plus 4 times negative 1 over 2, that's negative 1. Sorry, that's negative 2. So we have negative 2. And completing the operations, 3 minus 2 plus 3, that's 1. 1 plus minus 1, that's 0. Minus 6 plus 6, that's 0. 3 plus minus 2, that's 1. So you can see that we have an identity matrix, which means that the inverse here gotten is actually correct. So yeah, now we can do this again, but this time I'm going to go faster to show how easy this method is. So now using a different matrix B, we can try doing this, and we can see how easily you can try doing this with your calculator to test the speed as well. So we have this matrix and we're told to get the inverse of the matrix. So what we do basically is interchange those two parts and then change the signs of those two parts as well, and now we multiply by the determinant 5 and 2 is 10. So we have determinant is 10 minus 4 times minus 3 is 12. So this is minus 2. So we have 1 over minus 2, 5 minus 3 minus 4, and then 2. This is basically the inverse of the matrix B. And that's all we have your answer. If you can go ahead and do everything if you want. We have 3 over 2. We have 1 over 2 over here. Then we have -1 over here. And this is the answer. So you can see how quick that was. And that's how you do it. Thank you for watching, and I'll catch you guys on the next video. But for this, let's try using our calculator to confirm the answer this time. So we can go back to our matrix form. Matrix A, we have 2 2 2 by 2 matrix, we have 2, and then we have 3, we have 4, we have 5, and then here we go. You can see that everything actually matches. Oh, I actually made a slight mistake over here. 4 over 2 is actually -4 divided by -2 is actually 2, so the answer is 2. So you can always just use your calculator to get the inverse of matrix, or you can use this method, whichever is more convenient for you. You can just use it. So thank you for watching the video. As usual, please like the video, share with your friends and everybody, share with your family, share with your cousins, share with your brothers, share with your sisters, share with your mother and your sister and your uncle and your auntie, share with everybody this video and tell them to watch it. Peace. Thank you for watching, and bye bye.